This is the training video for Lab 0 spreadsheet training. This video you're going to use a little different than the other videos. So in this video I'm going to go through all of the solutions for the spreadsheet training. However, I would encourage you to work through the spreadsheet by yourself first and then use this kind of as a reference. I will point out though that in this video I'm going to go over a couple of extra tricks that I won't go over anywhere else. And so if you want to get really good at Excel, feel free to watch this whole video as well. So I'm just going to go through the instructions on here and solve each of the problems one by one. All right, and this first thing we have to do is go to Basic Spreadsheet Training. This is the first tab in here. This should be right where this is at when you open it up. And we're going to follow the instructions in bold lettering, notes in blue shading, reinforced principles. Okay, so first we're going to start with simple data entry. In Excel, each of these boxes is referred to as a cell, and we're going to click on this one. So right here it says click on the box at right, and we did that. We're going to type the number 11. Since we did that right, this spreadsheet has been coded with some background coding that you can't see to turn that cell green when it's correct. So if I enter 10 instead of 11, it's not correct. All right. The box, called a cell, will be shaded green when correct. Next, click on the cell at the right and type the word turtle. That turns green. Now, basic math operations, add 11 to the original number above. So we're going to try and add 11 to this number 11, but we're going to do it in this cell down here. And it tells us how to do that in the instructions. In this cell, we're going to type capital B4 plus 11. And that will then reference cell B4. If you look up here on the top, there's a bunch of columns. Each has its own letter designation. And on the right, there's all these rows. Each has a number designation. So we're saying go to column B, row number 4, which is right here. Grab the data from that. We're going to do B4 plus 11. Now you'll notice I typed in a capital B. What happens if I accidentally do a lowercase b? Well, Excel is still smart enough to figure that out, and we'll still grab the correct cell. But now if we click back on that cell, you'll notice that it capitalized that lowercase b to an uppercase B. Now let's learn some shortcuts here. Right here, we can type equals, and then instead of having to type B4, which can become cumbersome if you're using a lot of different cells in your equation, I can come up and click on this cell instead and type plus 11. Another way, oh, sorry, I wasn't reading the instructions. We want to multiply this last value, 22, by 7 here. So you'll notice I was able to hit equals, click on the 22, multiply by 7. Another way you can do this is if you're working on a laptop, you don't like using your mouse too much, you can type equal, and then you can actually scroll around which cell you're moving just by pressing up, down, left, and right. You can take that guy, multiply him by 7. My next one, Excel will also do numerical computations. Compute the operation 4 plus 2 equals 3. So let's just type in exactly what it says right there. You'll notice it doesn't turn green and it just looks like that. Why? What's the problem? Well, we forgot to put an equal sign in here. So we have to put an equal sign for Excel to know that we're typing in a function. Now it works. Let me show you something else real fast. Let's say you forgot the equal sign and it's a big long equation, or you messed up something else and you don't want to go through typing the whole thing again. Well, there's two things you can do. One is you can double click into here and then you can move around. You can put this equal sign here. Easier thing that I usually do is I'll come up here to this big bar at the top, and then you can just click around a little more easily. And there's some differences between working in this box and clicking into this cell down here, which I'll just let you discover as you explore the wonderful world of Excel. So now it's doing some math. So this here asks us to think about that same principle. If in cell B11 we had just typed B4 plus 11, what would happen? Again, we'd just get that text. And I'll let you read all the font in there on your own. You'll notice I get lazier and lazier about reading it as this video goes on. Now we're going to learn how to fill multiple cells quickly and how to use some functions. Okay, so first thing it wants us to do is click right here on cell B23, type the number 1, hit enter, then in B24, type 2, hit enter. Now, instead of having to just type 3, 4, 5, 6, which can become cumbersome, Excel can actually recognize some simple patterns. If it's a very complex pattern, Excel won't be able to figure it out, but if it's a simple pattern, like adding numbers together, then we can actually just type 2 of the numbers in the pattern in, and Excel can extrapolate. And if you look right here, there's this green little box right here. I can grab that box and I can drag it down to where I want the pattern to end. We'll get something that looks like that. Now you'll notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down. Now though, why are we getting these weird black lines, and why did we erase the black line under the number 10 right here? That's because dragging like this also copies formatting. So let me show you what I mean by that. So what you can't really see very well here is that above this number 1, there's actually a bold line around this black box that we were tracing around. So if I do 1, 2, 3, and I just grab the 2 and 3 and pull it down, you'll notice we're not getting any of those black those black lines. If I pull this all the way down to 10, though, you'll notice it still erases that black line under 10 because there was no black line under the last box I grabbed. So keep that in mind. Dragging numbers or functions down or to the left or right or up can be really useful and powerful, but it does affect formatting. You'll get to experience that as an issue as you work through some of the lab spreadsheets. All right, now that we've done that, let's calculate the sum of all of these numbers. All right, so we're going to do this using what's called a function. And for a function, this is just a built-in keyword into Excel that does something. So sum just sums numbers. And most of these functions have a name that's pretty similar to what they do. So for example, if you want to find the average, you'll use the function average. There's a lot of functions, and you'll learn a couple of them in this spreadsheet. All right, so for a function though, most functions have arguments. Arguments are information that you give to the function. So for the function sum, we're going to have to type sum and then opening parentheses. And you'll notice in Excel, depending on what version you have, it should give you some information here as to the numbers that go in here. And so the way that sum works is you just type in all the numbers you want. So I could do this manually, 1, 2, 3, 4, 5, 6, 7, etc. to calculate all these numbers. This is what's called hard coding. It's not very useful. Hard coding is when you type the numbers into your functions. I encourage you to avoid typing numbers into functions whenever possible. So what I would actually do here is you can click on these cells, and the sum function wants you to put a parentheses between each of these. You can do it this way, or the sum function will also work if you just come and click on this top cell, drag it down, and then we'll close our parentheses, hit enter, and that's the sum of all those numbers. Some other notes on this sum function. Let's say we want to sum up these cells and these cells, but not the middle ones. What you'll do is you'll select all these cells, put a comma, then select these. And then if you want to add other groups, like let's say you want to add these, you put a comma, add that, comma, add this, and it'll let you calculate all sorts of things. But of course, this will only turn green if we have the number 55. All right, now let's scroll down to simple graphing. So here we want to make the data in the cells at right mirror the data from above starting at B23. So the way we're going to do this is instead of typing all those numbers again, I'm going to hit equals. I'm going to come up click on that number. And then I'm going to, instead of dragging these numbers down, I can just grab that square and drag them all the way down. You'll notice it's saying I'm doing it correct. Another shortcut is I can actually double click on that box and it will autofill all the way down until there's no more text on the left. So let me give you an example of what I mean by that. If, let's say I delete this warning about older versions of Excel, and then I double click, now you'll notice it only comes down to 9. Why? Because there's no longer text on the left. So it keeps going until there's no longer text in the cell on the left. And that's just the built-in logic in Excel. I'll put that text back in there. Let's just drag these down. All right, so we've done all that part correct. Now it wants us to look at C40, which is this cell right here, and type the number 2. Then it wants us to go to the next cell, type the number 4, and it wants us to grab those, drag it down so that we have 2 sets of data. So this is 1 through 10, and this is 2 through 20. Another way we could have done this data is we could have put equals this times 2. I could have double clicked on that and it would have done the same thing. And you'll notice as it goes down, this cell is now doing 2 times 2. This next cell is doing this 3 times 2. Oh, excuse me, I burped in a teaching video. That's unprofessional. Now let's build a chart though. That's what we're trying to do here, or a graph. What we're gonna do is simply highlight all of these data, and we're going to come up to Insert. We're going to come over here, and there's a bunch of built-in charts in Excel. And oftentimes you're going to make the mistake of thinking you want a line chart or a line graph. That'll give you something that looks like this. I'll tell you this is completely wrong. And I've used a line plot professionally maybe once or twice in my whole life. This XY scatter plot is what you're actually looking for, and there's multiple options in here. Generally what you're going to pick is the dots with lines between them, or just the sharp lines. Let me show you what the difference is between the dots with sharp lines and the dots with curly lines, okay? So I'm going to click on this dots with sharp lines, and then I'm going to grab this data again. I'm going to insert another plot with the curly lines. So right now these 2 plots look essentially the same, and that's because they're really straight lines. But if there's any curves or bends in your data, so let me add a bend, this plot where it's just dots with sharp lines just draws a straight line between your dots, whereas the dots with smooth lines or curvy lines tries to make it look a little more curly. And you don't actually want to use this very often in science. I'm sure business people love it a lot, but in science it actually adds misinformation that'll be confusing to people. So we almost never use this plot. And so you're generally going to want to use this, sorry, let me grab this data again. Generally you're going to want to use the XY scatter with the dots, or with the dots with a line through them. And occasionally, if you have a lot of data, which will happen on some of your labs, it'll become really cumbersome to have all those dots in there, and then you'll just use the straight lines. What this is doing is it's still drawing straight lines between all of your points. It's just not showing you where the points are. So let me change this 4 back to an 8 again. You'll notice it still can handle the different positioning of the data, etc. It's just a little easier sometimes to see data this way when you have too many dots and the dots take up the whole plot. I'll delete that for now, and I will try and change all of these back to what they were before. Okay, let's go on now to simple statistical calculations. This is where we're going to learn how to calculate the average of our data. So right here, you'll see we have 4 data points. These are all masses listed in grams, and we want to find the average of them. So one way we can do this is we can have a closing parentheses. We have this plus this plus this plus this. I guess that was actually an opening parentheses, because here is our closing parentheses, divided by 1, 2, 3, 4. right? So that will give us the right answer. A simpler way, especially when there's a lot of data, is just to use the average function. So that's just equals average, opening parentheses. Then you're just going to highlight all your numbers, close your parentheses, hit enter. And then the next box, they want us to calculate the standard deviation. So the standard deviation is something we'll learn about in class. And in fact, there's a few things in here that have to do with statistics from class. I'm not going to explain what any of them mean in this lecture. I'm just going to, or in this video, I'm just going to show you how to actually do the calculation in Excel. All right, so for standard deviation, the formula is what's shown right here in A62. It's STDEV, so that's short for standard deviation. Then we have an opening parentheses. We'll highlight the cells we're interested in, closing parentheses, and hit enter. Now, something that's going to happen to you a lot is that you're going to forget to type that closing parentheses. Excel is smart enough to catch most of your simple errors and fill in that parentheses for you. If you've got a bunch of parentheses, Excel will get confused as to where you want the closing parentheses. And there's a few other simple things that Excel can figure out that you messed up on and correct them for you, but generally it's pretty limited in how good it is at figuring out what you actually want. All right, now let's go down here to calculating our buoyancy correction. This is something you'll have to do starting in lab 1. But all it wants us to do here is in cell B68, wants us to type in this mass value of 10.3423. Then in B69, it wants us to type in the density of air at 25 degrees here in Provo, and that is about 0.0010 grams per milliliter. Wants us to type in just the number 8.0, and finally it wants us to type in 2.34. These numbers right here, 0.001 and 8.0, are actually numbers you're going to use in your lab. So those are the real numbers for these values going forward. And those will actually, or what those are, will make more sense when you actually need to use them. We won't worry about that too much now. Now it wants us down in this cell right here to calculate the buoyancy correction for our mass. And it gives us the equation right here. Now this right here, you'll notice there's a lot of parentheses. Excel understands your typical order of operations that you learned way back when, the PEMDAS acronym, right? So parentheses, exponents, multiplication and division, and addition and subtraction in that order. And so oftentimes, if there's a problem where you're not calculating the right number, you usually have forgotten a parentheses somewhere, or parenthesis somewhere. So here, you'll notice there's quite a few parentheses. I'm actually going to use a little fewer, or slightly fewer parentheses. So I'm going to start with equals. I'm going to click on my mass right here. Then I'm going to multiply times a parentheses. I'll point something out really quickly here. Now let's say we want to do 10.3423 and we want to multiply it by 2. Excel can't understand this syntax. So if I hit enter, it'll give me a reference error, meaning basically it doesn't know what it wants me to do. So when you're multiplying by a parentheses, you always have to put in an asterisk. The asterisk is the multiplication to sign in Excel. Probably should have said that earlier, but now it can figure out what I'm trying to do. All right, but let's finish this equation here. So what we're going to want to do is do 1 minus the dA over dW. You'll notice in these cells up here, it's labeled which ones are dA, dW, d naught, and m. And so it's wanting dA, which is going to be B69 up here, and it's wanting that divided by dW, which is B70. You'll notice in this equation that has parentheses around this division, but because Excel understands order of operations, it's going to understand that it needs to divide those before subtracting this number from 1. Okay, so we'll close those parentheses. This is the denominator of our equation. We're going to divide by the denominator. Sorry, the numerator is on top, so this stuff's the numerator. We're going to divide by the denominator here. So that is going to be 1 minus dA over d naught. So dA divided by d0, if that's easier for you to understand. We're going to close that off and hit enter, and Excel is happy with us. All right, if you have any questions about any of this, of course, let me know and I can help you out. Now let's go to entering exponents. So here we're going to learn a little bit about formatting cells and what sum notation means in Excel. So here in this first cell, it just wants us to type the number 1 million. All right, I think I messed up. All right, it's 1, 2, 3, 4, 5, 6 zeros. Okay, maybe it's not going to turn 0 or turn green. Oh, I didn't read the instructions. It wants 1 million and 1. 1, 2, 3, 4, 5. There we go. Okay. Now we want to type in this next cell 1e to the 6th. Okay. Now what does 1e to the 6th mean? Well, when we type that in, if we come and look at this text box up here, where it actually stores what is in the cell, you'll notice that it's the number 1 million. It's the number 1 million because e to the 6th means times 10 to the 6th. So when we typed in 1 e to the 6th, what we're saying is not 1 times the natural e to the 6th power. What this means is 1 times 10 to the 6th power, which is 1 million. Now it wants us to subtract B84 from B83. Most people will do this backwards, or most people that get this wrong just subtract these in the opposite order. So we're wanting to do B83 and subtract B84 from that cell. You'll notice this is 1.00 e plus 00, which means 1 times 10 to the 0, which is equal to 1 times 1, which is the number 1. All right, so we finished our first tab. Now in Excel, data can be stored in different tabs, and those tabs are down here. So we're going to switch to our next tab, which is formatting. Okay, we're going to start in the formatting tab by using the sum function to sum up all of these masses. So we're going to sum all of these right here. And it turns green. But we want to format this so it's showing the right number of significant figures. Now down here, these instructions should work for any version of Excel, whether it's a new version or old. We'll start with those. So what it wants you to do is click on this cell, and then right-click on it, go to Format Cells. Okay, and then it wants you to format what way the number or data is shown. Right now it's in general format. There's a lot of different formats. So if I hit currency, you'll notice it puts a $sign in front of that 8, and it rounds it just to 2 decimal places because that's how many decimal places you can actually have in currency. There's other things like date, time, percentage, etc. But the instructions down here want us to click on number. So now we have the number. It's rounded to 8.60. The instructions want us to round this to 4 decimal places, so we'll change the number of decimal places there. We'll hit enter. Okay, so that is the version of formatting numbers that works across pretty much all Excel, and it should work on most Mac programs, though those are a slightly different functionality, or functionally, I guess. But in almost every version now, you can actually, instead of going right-clicking into anything, you can come up to the Home tab up here and change the format directly right here. So right now this is general. You just click on number, and now you'll notice, oh, we don't have the right number of decimal places, but there's also these buttons right here that'll let you increase and decrease the number of decimal places you have showing. And you can actually do that simultaneously. If you grab a bunch of cells, change the number of decimal places showing, you can change it for multiple cells at once. All right, now let's come down here to formatting cells for color. So this wants us to change each of these cells. So the background is the indicated color, and then it will also want us to change the text inside to the same color. So what we'll do to change the background color, we can right-click on the cell, go to Format Cells, and here we can go to Fill. We can change, for example, the black cell, we can change it to be black. We'll hit OK. Now it has a black background. Of course, the text is black as well. Now let's show how to do this to change the text color. So in here, you'll notice there's no text tab up here. You have to go to the font because we're editing the font. You'll change the color, and we'll change it here to white. You'll notice now that it's black and white. An easier way of doing this instead of clicking in there is you can also just come up to here. This paint bucket is our background color. You can choose any of these. These are the defaults, and then of course you can do more colors down here. So we want it to be black, so we'll leave it at black. And the text color we want to be black. So we can either choose black or we can click this automatic button that changes it to the preset black color. This cell wants us to be blue, so let's come up to our paint bucket. I'm not looking for a specific shade of blue here, and I don't even know if this column right here and this column, if they're different. I think to me they're both blue. If you ask my wife and daughters, I'm probably wrong, but I'm the professor here. Take that, daughters. So I'm just going to choose a blue, and then for the text, I'll also choose a blue. If these are different shades of blue, I'm not going to mark you down because this is really just to teach you how to format colors. I'm not looking for anything specific, but now it's blue. Let's do that for the green as well. I'll pick a light green for the background and a dark green for the text. We'll do the yellow, yellow. And finally, the no color cell. So there is a no color background option, which is different than a white background. And we're not going to get into any scenario in this class where you'll notice the difference, but format-wise, there is technically a difference. So I'm just going to hit no fill. Now, as for the font color, you can't actually give the font no color. It has to have a color. And so we will just change that to white. All right, now let's go on to the next tab, which is copy and paste. All right, in the copy and paste tab, we're going to just learn about some simple functionality. Again, what it wants us to do is just highlight these data from cells C10 to C14. We're going to hit Control Copy, which is Control C. You can also right-click on the data, come up here and hit Copy, but Control C works. And then for most pasting you've done in the past, you might hit Control V, and that works fine for this first row. But you'll actually find out pretty quickly that that doesn't always give you the results you want in Excel. The reason is because oftentimes you are copying formulas. So for example, if I highlight all these data from C10 to C14, oh sorry, at the beginning I highlighted A10 to A14. If I highlight C10 to C14 and hit Control C, then come over here to the next cell and hit Control V, you'll notice that the numbers here are not the same as the numbers here. Why is that? Well, it's because we copied the content of the cell, not the number being displayed in the cell. So the content here for this cell that equals 2, if we come up here in the text line, you'll see it's a function where we're multiplying this number in B10 times 2. So when we copied this formula, it didn't actually copy B10 times 2, now it's C10 times 2. So why is that? Well, what it actually copied was this cell is looking, it's saying the cell to my left, multiply that by 2. So over here, it's still taking the cell to the left, multiplying it by 2. And that type of copy and paste can be really valuable. It can also be very frustrating if it's not what you're trying to do. So there's multiple ways to paste. So if I come in here and I copy this data, I come over here, I can right click, and there's this paste special button where you can choose formulas, values, formats. There's a bunch of different things in here. So if I hit values, you'll notice now it's just copied these values over, but inside the cells, it's just hard-coded numbers now. If I copy these guys over here and do formulas, that's what I originally had. And now let's go to over here to our last row. I forget what I'm wanting you to do here. Paste only values. Now repeat 3A and 3B. Okay, so now we're going to take this data in C10 through C14. We're going to come over here, and I could either highlight all of these or just select the top one and it'll fill down. I'm going to, I can click into paste special and hit values. In more recent versions of Excel, I can also just right click, come up here to this clipboard with the 1, 2, 3 down here. That'll let me paste what I want in there. There's a bunch of different options. There's formulas. You can transpose your data, which will make it show up in a different axis. So if you're going in a column, it'll go to a row, or if you're copying from a row, it'll make it a column. There's a bunch of different paste special options in here. We're not going to go through all of them because most of them aren't very necessary for what we do. Right. Now this is asking what happens if we delete cells B10 through 14. What's going to happen to all these? And it wants you to give a little explanation. I'll just show you what happens and you can describe it in your spreadsheet. Okay. Now let's go on to cell references, gases. So I've shown you already how I can set this. I'm just going to go through this stuff down here. You can read the instructions up here. The instructions will tell you to do what I'm doing. But I've shown you how I can type in this cell, we're going to have this cell times this cell. And that's really powerful, right? And then if I drag this around, now you'll notice that this 3, that's equal to 3 times 3, this 12, it's looking at the cell above it and to the left, just like this one was looking at the cell above it and to the left. So when I dragged this over here, it just dragged that functionality over. And if I highlight both of these, I can drag them down. It gives me these guys. Let me point something else out here to you real fast that's not really related to that. But if I grab this box, I can't actually drag it both down and to the side. You have to either do it down or to the side first. And then once you do it in one direction, you can do it in the other direction. Okay, now this is useful, but usually in a table, I'm not looking for the other cells multiplied together to give me a value, right? What you'd usually expect in a spot like this would be 4 times 2. So I'm going to show you how to make it so it doesn't copy which direction you're at. So it's not going to say, look at the cell to my left. We're going to tell it to look at a very specific cell when we are moving around. So the way we're going to do that is in this cell now, I'm going to do 3 times 1 again, but I'm going to make it so that it always looks at this cell with a 3 in it. So that's cell E12. So I'm going to type equals $E. So that means we're going to always look at the E column, $12. Oh, forgot I was in the middle of typing. Sorry, let me do that again. A12. So now it's going to hold on to that guy permanently. We're going to multiply that by $D, what is that? 13. And now this is looking at this cell that says 3, multiplying it by 1. So if I drag this around here, even over here in this corner, it's still looking at 3 times 1. Okay, well that's sort of useful. It is actually very useful, but here we want to be looking at 4 times 2. So how do I make this dynamic so that when I drag it around, it just gives me the references that I want? Well, what we can do is say, hold the column constant but change the row, or hold the row constant and change the column. So the way we're going to do that is here in this table, we'll do equals column H, which will be the column we're in right now, $12. And what that's going to do is it's going to constantly look at this cell. So if I drag it this way, now it's looking at that 4. If I drag these down, so if you look, now these guys are just pointing at these guys, but now we want to take this row times this column and fill in this matrix in here, right? So now we have H12 in there. I'm going to come in and add times $G and then 13. That'll get us pointing at that 1. Now if I take this, I scroll it around, oh look, now we have a reasonable table where we're actually looking at the data we want. Now typing $ in can be cumbersome, just like typing in cell addresses. So I actually don't ever type $ in on a normal day. So if you come into this box up here, the text field, if you hit the F4 key, you'll notice that it moves your $. So if you start with just a cell address right here, so G13, if I hit F4, it'll put a $sign in front of the G and a $sign in front of the 13. If I hit the $sign again, now, or sorry, if I hit F4 again, the $sign's just in front of the 13. If I hit F4 again, the $sign's just in front of G. So that's a quick, easy way to format those. It doesn't take a lot of time. All right, now down here, this is an application where we want to fill in this table. We want to figure out the pressure times the volume to figure out how much stuff is actually in these cylinders. I'll let you read through this paragraph on your own to figure out exactly what we're doing. But we're going to need to convert from PSI to atmospheres. So I have a conversion here between atmospheres and PSI. We're also going to need to convert between cubic feet and liters, okay? So let's start with this. So we're going to take this cell times this cell. Then to go from PSI to atmospheres, we're going to have to divide by 14.7. And then to go from cubic feet to liters, we're going to have to multiply by 28.3, etc. Right, so this cell looks right. Now if I drag this around, we don't even get numbers most of the time. We just get this divide by 0 error. So let's take this a little bit slower and figure out what we're doing. So first, I typed in all these conversion factors in kind of piecemeal, so let's just do that a little more slowly. So we have 500 PSI. We notice 1 atmosphere is equal to 14.7 PSI, so we're going to divide by 14.7 PSI. Now this cell right here is going to be constant for all of our pressures, converting from all of these pressures from PSI to atmosphere. We're always going to have to look at that same cell. So let's hit F4 and make that a constant, okay? So now what happens is I drag over this way. Well, we're constantly looking at that guy. And since this was the only thing we were dividing by, we're no longer getting divided by 0. So that's good. But you'll notice that now, right here, we have 500 divided by 14. That's correct. Right here, we have 1,000 divided by 14. That's correct. But if I come down here, now we have we have 34 divided by 14 when this guy should actually be on that 500. So one thing we could do is we could click through all of these cells and we could move that back. Or of course, we could just set it constant. Now we don't want it constant as we move across the row. We just want it constant as we move down this column so that any data in this column is still referencing that 500. So what we're going to do is we're going to come into our text field and click on the C20. We'll hit F4 once. That'll make its column and row constant. We don't want that. We just want the column. We just want the letter C constant. So we'll hit F4 until a $sign is on there. Now if I drag this over, I drag it down, I failed. Oh, yeah, sorry. We don't want the column constant, we want the row constant. fix that. My bad. So we want row 20 to be constant, but we want to be able to change columns. Sorry, that was faulty logic on my part. Okay, now what we need to do is do pressure times volume. So in here, we'll do times our volume, and then we want to convert this volume from cubic feet to liters. And so we know 1 cubic feet is equal to 28 liters. So we'll do times that cell. This cell, of course, we're going to want to keep constant. So we're almost there. Right now, we get one row that, or one column that turns green, but everything else has problems. And that's because now this B21, we want to keep the column constant this time, but we want to be able to change rows. So we will hit the $sign until the $sign is on that B21. Now I can drag that around and everything turns green. So this is one of the pages that people have the most difficulty on. You'll notice even I messed up on it for a second. So if you have questions about it, feel free to let me know. Or if the logic doesn't make sense, feel free to let me know. Also talk to your group about that. On this page, what we need to do is calculate the golf scores for 4 players, Rufus, Bubba, Jake, and Charlie. So what it's going to have us do here is just calculate some of this data using formula. Now in the instructions, it actually wants us to calculate all of these cells by themselves, then do the averages, then do the standard deviations. I'm going to do it slightly out of order here. So I am going to figure out the total strokes that Rufus took, and to do that, I'm just going to sum up how many strokes he took at each hole. All right, so he took 111. And then I'm going to figure out his average number of strokes. For that, I'm going to use this function equals average, parentheses, highlight what I'm looking for, hit enter. Then for standard deviation is one that can be hard to remember the function name for just because it's not the intact word, but it's stdev. And we're going to highlight all of those. So now I'm going to grab all of these, and I can either drag these down or I can double click on this square. I'm going to double click on it first. Now the reason I wanted to show you this is because here it's actually not advantageous to double click on it, because now it calculates the total average strokes and standard deviations for the par of each course. And maybe you would want that information, but for this assignment, I'm not asking for it, so I don't want to calculate it. So I'm going to hit undo on that. And here I'm just going to grab this green square and pull it down. I'm also going to grab our average and standard deviations all together, reformat these a bit, and you'll see why a bit later. I'm going to leave some extra decimal places, but I'm going to reduce those just so they're cleaner numbers, so they're a lot easier to read if you get rid of all those decimal places. Okay, so that's how you do this page, but then there are a couple of questions down here that it wants answered. The first one was, who was the winner? So if you don't know how to score golf, whoever takes the fewest number of strokes to get the balls and the holes wins. And so up here, we'll look at the total. So the total, the lowest total was 101, and that belongs to Mr. Jake over here. So I'm not going to type in anything. I'm just going to hit equals Jake. Then down here, which player had the least variability in the number of strokes used? So variability is asking about the standard deviation. The standard deviation is a measure of variability. So the lowest there was, let's see, equals Charlie, because Charlie has the lowest standard deviation. Even though he lost entirely, he had the highest average stroke count, he was the most consistent, which is interesting. Also, these numbers are made up, so it's not that interesting. All right, let's go on to the next tab, the Help tab. So here, we're going to be figuring out how to count the number of cells in here. So this first problem, getting help finding other functions. So what this wants you to do is use the help files on Excel to try and find a function. I actually don't ever use the help files on Excel. I like to search Google. You can usually find things a lot faster there. But we want to be able to count how many cells in here have numbers. So which have numbers and which are empty. So to do that, we're going to use this function that's really cleverly named as count. Open parentheses. We're going to highlight the whole area we want to count, and we'll hit enter. Now, something you should recognize about the count function is it does not recognize text. So if I type in here different words, it's not going to count those words. It's just going to count numbers. So count only counts numbers. If you want to count everything, you actually need to use the count A function. So count A function works almost the same way, except it also counts text boxes. So any cells that aren't empty, it counts. But of course, that'll make your box wrong if I still have these text in here, so I'm going to delete them and get a 72. But now let's say you're looking in an array of data like this, and you only want a specific value to be counted. So a great example of this is, let's say you're looking through a population of people and you want to figure out how many people are named Tom. They've all just got all their names listed in random order. How do you count just the Toms? So for that, you're going to use the count if function. So if is a common programming word that means if a condition is met, do something. So here we're saying count if a condition is met. So in here, you'll notice when I put the opening parenthesis, it gives me the format it wants. So it wants the range. The range in this case is the range of data that we're looking through. We'll put a comma, and then the criteria here is what we say what we're looking for. So I'll just type 1.9987. I'll close that off, hit enter. Okay, now it's 55. This COUNTIF function can search for text as well, but since we have it just looking for a number, it's not going to find it. But let me show you how it works for looking for text. If, let's say I'm looking for the word text, and I just type the word text in here, it's not going to count it. And that's because plain text like this usually implies that you're typing in a function. So if you're looking for a word, you're going to actually have to put it in quotes in here. And now it can count the word text, right? And there's another one. If I misspell texts, so if I put an S on it, for example, it's not going to count that. It's only going to look for exactly what we want. And there's this wildcard in here, the asterisk. If you use that in a text string like this, then it'll say anything that starts with text, anything after that also counts. Okay, I'm going to hit Control Z to get this back to looking like what we originally wanted. All right, now let's move to more stats trophies. On this page, we're going to be comparing some data. I'm going to go through the calculations here. I'll let you read the instructions on your own. But basically what we're going to be doing is comparing this data set to this one. Now, in the lecture, I believe it's lecture 3 or 4, we go over the significance of what we're doing on this page. Right now, I really just need you to see how to type in some formulas. And since you'll probably be working on this before you get to those lectures, I've included some equations you'll need right over here. All right, so first, right here, we want to calculate the averages of these guys. So we'll type equals average in here. We'll highlight these. You'll notice right away that this box turns correct for the calculated pooled standard deviation. This is actually, I'm not going to say that it's an error I made in programming this, but it's not correct yet. This is assuming we're correct based on standard deviations of 0. But you'll notice as soon as we put in the equation, can't do that while I'm talking, can't think well. If I put in the standard deviation for these guys, you'll notice now it's not correct. Now it wants an actual number. So up here, I've calculated the averages for these two data sets, and I've calculated the standard deviations. These should be the standard deviations for each data set separately, okay? Now in the pooled standard deviation, we're going to combine the uncertainty from each of the two populations here. We're going to be doing that using the equation that's listed there on the right. So here, first we're going to use the square root function because we're going to want to put everything in there in square root. So square root is also abbreviated to SQRT. Most long words are abbreviated when they're turned into a function. And if you look at this equation, we have a bunch of stuff on the numerator on the top. So we're going to put a opening and closing parentheses there for the top. We'll click inside there. Now let's calculate this. So S1 is our first standard deviation, and it doesn't matter which order you choose these in. But I'm going to take S1 squared. We're going to multiply that by N, which is the count of data in this sample. So I'm going to make some more closing parentheses because that's in the equation. And I'm going to use this function count to actually count my data. You don't have to do that. You can count it by hand if you want, but I tend to use functions whenever possible to minimize hard coding. That way, if I have to delete one of those numbers, I don't have to change this formula at all. And I'll show you what I mean by that in a second. Oh, I'm not done yet. I hit the wrong key. I know Excel, stop getting mad at me. So now we're going to take all of that. We're going to multiply it by this second standard deviation squared times the count in our second data set. So the number of measurements over there, minus 1. Now we have our numerator all set up. We're going to divide. Now I'm going to make a mistake here on purpose to illustrate something that happens all the time. So on the bottom here of this equation, we want the counts of both data sets minus 2. So I'm just going to do my count function over both data sets. I'm going to close that, minus 2. Then I'm going to close up my parentheses here, hit enter. Now notice it's saying there's a number error. Why is that? Well, it's actually because I've made a number of mistakes in entering this, and they all have to do with parentheses. So first off, I actually forgot to close my numerator parentheses. So I need to put one right there. And you'll notice as you scroll through these parentheses, it will highlight the parentheses as you pass it. So if you hit left or right over the parentheses, it'll highlight it and the corresponding parentheses. So that's a good way of checking which parentheses are checked. So now, if I hit enter, it's going to get mad at me because now I have an extra parentheses on the end of my equation here. And in the example, it wants me down to just 1. So I'll hit yes. Okay, we're not perfect yet. Why not? What are we missing? This is something you will probably mess up on several times as you use Excel, is that I did not put the denominator all in parentheses. So we're dividing all of this by the count and then taking that whole thing and subtracting 2 from it. But what we want is this count on the bottom minus 2, right? Now we have a correct value. Troubleshooting these guys can be tricky. I often recommend just working with a partner while you do it. That can save you a lot of headache. Now let's calculate a value of t. So that is using this equation over here to the right. So for t, we're going to take the absolute difference between x bar 1 and x bar 2. So x bar, if you haven't gotten this far in the lectures, is the average. So this is average 1 minus average 2. Since it's in absolute values, you don't actually need to worry about which one is data set 1 or data set 2. So we're going to type in equal, and then the absolute value function is ABS with parentheses. So we'll do average 1 minus average 2. We'll close those parentheses off. And then we're going to divide by our S pooled. Then we're going to multiply by the square root. I'm going to put this in parentheses of the number of data in data set 1 times the number of data in data set 2. And we're going to divide that. Now, some of you might think I made a mistake by not putting the numerator in parentheses, but since we're just multiplying those, the order of operations will still work out to get us the right answer. So, but we'll do the count in data set 1 plus the count of data in data set 2. We will close off our parentheses. And let's see, I think that's all the parentheses we need. Oh, I missed the parentheses, but there we go. That's our actual calculated t-value that we're looking for. Now we need to enter our degrees of freedom. This is something you'll also learn in the lecture, but that is just the number of total data minus the number of data sets. So here we have 2 data sets. Now, is this going to work as is? No, it's not. Why is it not going to work? Because I hit count on these 2 cells up here, but they are full of text and not numbers, so it's counting 0 numbers, but we want to count in text. So we can change that to count A. Of course, you can count 2 if you want. Now this t inverse function right here, or sorry, we need to look up a t-value from a table. And instead of actually going to a table, Excel will let you calculate this value manually. So you use this t inverse function. And for a probability, we're going to put 0.05. That corresponds to a 95% confidence interval. And if we wanted a 99% confidence interval, we'd put a 0.01 probability. So the probability is just 100% minus your confidence level divided by 100%. And then for our degrees of freedom here, we could count this again or figure this out again, but we just calculated it in this cell. So we're just going to click on that one. We'll hit enter. That guy is correct. Now, is the difference significant or not? You will have to understand what a t-test is to answer this question, but the answer is yes. And if you've gotten past lecture 4 and you don't know the answer to this question yet, then feel free to reach out to me and I'll help you understand it. The last page is linear regression. So making lines and plots, etc. in Excel. So the first thing we want to do, so this is real data. So this spreadsheet was originally built by Dr. Macedoni, and I've updated it a little bit over the years. But this is actual mileage from a car that he bought in 2009. So it's got its starting mileage, the cost of gas that he spent, so the number of gallons he put in there, the number of miles, and he kept pretty good track of this for every week for, what is this? It looks like about 2 months here. So this is actually all real information, and this is just a picture that he stole off the internet. It's not his real car. But we want to look at, what we want to do is calculate the mileage per day. So to do that, we're going to calculate the slope of this data, which is rise over run. So if we consider our miles are y-axis data and the number of days are x-axis data, then miles per day is just rise over run. So we'll calculate our slope. We'll do this using the slope function. So it's going to ask for our known y's first. I don't know why Excel does this. I wish that it would ask for x's first, but in all of its functions, it asks for the y values first. We'll grab all of our y values, and then we will grab all of our x values. Excel can interpret dates here and put them on an x-axis for us, so we don't have to worry about anything. But there is our slope. So he was using about 43 miles per day. I don't know where he was driving all that distance. All right, now this isn't asking you to do this, but there's also an intercept function. So if you're trying to figure out your y equals mx plus b equation, you can actually also use this intercept function to calculate your b value. And again, you just highlight your y values and you highlight your x values and you hit enter. It's not going to turn green because the spreadsheet's not looking for that. Now, these are two functions that you can use to calculate your slope and your intercept. We're going to be doing some more complicated math in this class. And so what we're actually going to need to use a lot of times is what's called the linest function. The linest function calculates your slope and your intercept. It also calculates some uncertainty in your slope and intercept and some other values associated with your line. So let me just show you how to use the linest function here. So what you're going to do is highlight an array of cells. So you're not just going to click on one, but you're going to need to have an array that has at least 2 columns and several cells, depending on how much information you want out of your linest function. And we'll just type in equals linest. So linest is short for line estimate. And there's a lecture that talks a little bit more about that, so we're not going to get into the meaning of it too much. But you'll type linest, you'll do a parenthesis, and then you'll highlight your y values again. Oh, I missed one of them. Oops, I messed up. All right, let's try that again. All right, we're going to do linest. Oh, we're typing in the wrong cell. I want to be right here. We're going to do linest. We're going to grab our y's. We're going to grab our x's. And then we will type in comma 1, comma 1. In the lecture, I'll go over more of why we do that. We'll close this, and we'll hit enter. Okay, now that is not filling all of the data. So let's grab this and move it around. Wait, this intercept is very different than that, and all of these values are giving us a value error. Why? Well, because we actually did this linest function wrong. So let me undo here a bit. Okay, so this is why you have to highlight all of these. The linest function is what's called an array function because it fills an array of data. But you have to give it a special instruction to tell it, I want you to fill an array. So let's type this all back in again. Linest equals your y's, your x's, comma 1, comma 1. Now to tell Excel that you're using an array function and you want it to fill an array, you have to hold Control, Shift, and then hit enter. And now if I click on any one of these cells, so you'll notice here really fast that our slope is the same up here and our intercept is the same up here. But if you look up in the text field, if you look up in the text field without clicking in, you'll notice that the whole thing's covered in curly brackets. And curly brackets is Excel's way of saying this is an array. And so Excel just can't do that by itself without you telling it to. Now you'll forget how to use the linest function later on in the semester, and then either I will have to retell you or a classmate or this video or whatever. But if you do forget how to use the linest function, don't feel embarrassed. Please just come talk to me. It'll save you a lot of time. All right, now the last thing we need to do is make a scatter plot of our mileage. So let's scroll back up here. I'm going to highlight all this data. And I'm actually going to grab data and mileage as well. And Excel can automatically put those in as data labels for me. I'm going to go to Insert. I'm going to, again, choose my XY scatter plot. I don't need this data connected by lines. Those lines are fairly meaningless, actually. So I'm going to just click on X and Y. Now, it did not do a good job of giving me axes. I'm not entirely sure why. If you have the latest version of Excel, you can write, or you can click on this plus size and give yourself some axes titles. And I can put in here date and mileage. Okay. Now, another quick note is generally in science, we don't like all these hash lines. Generally get rid of them. You can just click on them. You'll notice that it highlights the vertical lines and the horizontal lines separately, but you can just click on them and delete them. Okay, so here's our data though. On a plot, we got our mileage on our y-axis, we've got our data on our x-axis, and we want to add a trend line to see if so a trend line is useful for predicting data, right? So to add a trend line, what you're going to need to do is click on your data on the plot. And in pretty much all versions of Excel, you can right-click now and go down to Add Trend Line. Now what happens next is a little different. If you're in an older version of Excel, you usually get a pop-up window, In newer versions of Excel, you get this box over here. We're going to go down now and hit display equation on chart and display arc squared value. So let's compare really fast. Oops, I moved the wrong thing. Let's compare really fast this information right here. So we have our slope 42.911 compared to 42.91062. This slope is rounded off. That's why it's not looking the same. Then we have minus 2 e to the 6th, or 2 million. We compare that to this slope. This was negative 1,596,800, etc. So if you want to change this, you can actually come in and there's an option in the formatting. There's an option to format this. Usually I won't make you do this, but just for your reference, you can change it to a number. Now you can see it's giving you all sorts of values. And these are much more similar to those values. And you can change the number of decimal places if you want. You can go out to 16 decimal places if you're crazy. But unfortunately with this, the downside is that you can't give your slope and intercept a different number of decimal places, even though they should generally have different numbers. I'll show you a couple other things in this video real fast. With this trend line, right now I have a linear trend line. If you're trying to fit data to an exponential, you can also choose an exponential. There's a logarithm, polynomial, and you can change the number of, or change the order of the polynomial in there. You can change this to a power function or a moving average. Now with a moving average, what this does is tries to take the average over the period, which is the number of data points on either side of your data, and tries to figure out, or it's probably the number of data points, sorry, below your data, and tries to figure out the most recent average. You'll notice it doesn't have a equation on it or an R-squared value. Those don't go with moving average. Right, and that's it for the functions and math on here. I'll let you answer this last little question. And of course, if you have any questions about any of this, feel free to reach out to me and let me know. All right, good mathing.